Number 1. Circle O is centered at the origin. In the diagram below, a quarter of circle O is graphed. So that little piece right there. Which three-dimensional figure is generated when the quarter circle is continuously rotated about the y-axis? So here's what you need to picture. Imagine taking this part of the circle and picking it up out of the page and spinning it around the y-axis over and over again so that it creates this shell sort of figure when it does that, and it's going to be in 3 dimensions. Now, it doesn't look like a cone. It looks like part of a sphere, but not a full sphere. It's actually half a sphere, which is called a hemisphere. Number 2. A right hexagonal prism is shown below. A 2-dimensional cross-section that is perpendicular to the base, so we're cutting it this way and seeing what the cross-section is because that would be perpendicular to both of those hexagonal bases. Which figure describes the 2-dimensional cross-section? So if you try to picture what would happen, in this case if you cut it right down the middle, what kind of shape that would be? It looks to me like it would be a rectangle. Now if you're having trouble seeing that, picture this. I have a hexagonal prism, that dark shaded part, and that red thing is a cross section if I cut it perpendicular to the base. And it's always going to be a rectangle regardless of how I move it. If I instead cut it parallel to the base, that's when it would be a hexagon straight on through. And of course there are other shapes I can get by cutting it diagonally and just cutting off a corner like that to get a triangle. Number 3. A basketball has a maximum circumference of 29.5 inches. Which of the following would be closest to the volume of the basketball? Well, remember, a basketball is a sphere, and the volume formula for a sphere is 4/3 pi r cubed. But I don't have the radius right off the bat. I'm told that the circumference is 29.5 inches. But I have a formula for circumference. I know that circumference is equal to pi times diameter. So if I substitute that 29.5 into the circumference formula, I can solve for the diameter and use that to get my radius. So if I divide by pi on both sides of the equal sign, pi divided by pi is just 1, and 29.5 divided by pi, if I do that in my calculator, I find that my diameter is about 9.39014 and so on and so forth. I notice that none of my answers are particularly close, so I'm not even going to do any more decimal places. I'll divide this by 2 to get my radius, to find that my radius is about 4.695 inches. So when I plug into the volume formula, 4/3 times pi times 4.695 cubed, not squared. Now, if you don't know where those buttons are in your calculator, I'm going to hit alpha, then y equals to bring up the fraction bar if I hit enter. 4/3, I'll arrow out of there. Second, to get the pi button, that caret on the right-hand side below clear. And then I'll do a set of open parentheses, 4.695, close parenthesis. And to get the cubed button, if we hit the caret right below the clear button, I could put in whatever exponent I want, so I'll type in 3. And then when I hit enter, it's about 433.5, and the closest one to that would be 435. Number 4. The diagram below shows 2 figures. Figure A is a right triangular prism, and figure B is an oblique triangular prism. That just means it's slanted between the bases, and a right triangular prism, they're connected with rectangles, not parallelograms. The base of figure A has a height of 5 and a length of 8, and the height of prism A is 14. The base of figure B has a height of 8 and a length of 5, and a height of prism B is 14. Realistically, all this is saying is that these triangles would have the same area. If you think about how you calculate the area of a triangle, 1/2 base times height, here it would be 1/2 of my base of 5, my height of 4, and that area of the base would be 20 units squared. The area of this base would be the same thing because my base is 5 and my height is 8. Remember, multiplication is commutative, it doesn't matter what order it's in. So the area of these bases are the same. But the height of the prisms are also the same. So by Cavalieri's principle, since figure A and figure B both have the same base area, and the same height, their volumes are equal. That's what Cavalieri's principle states. Since figure A and figure B both have the same base area and the same height, their volumes are equal. So anytime you see Cavalieri's principle, or you're comparing two figures that have the same base area and they go up the same amount, have the same height, you could always state this as a reason for why their volumes are the same. Number 5. A packing carton in the shape of a triangular prism is shown in the diagram below. What is the volume of this carton? Well, remember the volume formula for any prism would be the area of the base times the height. And in this case, my base is a triangle because there's a base on the front and a base on the back. This way it's just lying down instead of standing straight up. So, remember the area formula for a triangle is 1/2 base times height. Notice those bases are different. Big B is the area of the base. Little b is just a length of a base. So the area of that triangle would be 1/2 base times height. And the height of the prism is the distance between your two triangular bases. In this case, they're 10 units apart. So the volume of this entire triangular prism would be 120 inches cubed. It's inches cubed because it's a volume in 3 dimensions. Number 6. The greenhouse pictured below can be modeled by a rectangular prism with a half cylinder on top. The rectangular prism is 20 feet wide, 12 feet high, and 45 feet long. The half cylinder has a diameter of 20 feet. Find the volume of the rectangular prism portion of the greenhouse. Well, that's this piece down here, and the volume of any prism is the area of the base times the height. But to find the area of, let's just say, this front base right here, it's just a rectangle. I could do length times width, 12 times 20. And I could multiply it by the height, which is how far that rectangle goes back, and that's 45 feet. So the total volume of just the bottom part is 10,800 feet cubed. Now, if I want to try to find the volume of the half cylinder on top, remember the formula for a cylinder is pi r squared times the height. And if this is half a cylinder, I want to remember to take half of that. They tell me that there's a diameter of 20 feet. So if I need the radius to plug into the formula, I can plug in 10 feet for the radius. The question is, what is the height of this half cylinder? And the height of any prism or any cylinder is the distance between your bases. Your bases for this half cylinder are semicircles. Well, you got one semicircle in the front, and the other one's way back here that's 45 feet away. So picture a cylinder, instead of standing straight up, it's lying on its side. But the height is still the distance between those two circles. So 45 represents the height of this half cylinder. And again, because it's a half cylinder, I'm going to divide it by 2. And they say round to the nearest cubic foot. So when I type that into my calculator, it's about 7,069 cubic feet. So the total volume of the greenhouse would be the sum of these two, the top part plus the bottom part, to be about 17,869 feet cubed. Number 7. A solid metal prism has a rectangular base with sides of 4 inches and 6 inches, and a height of 4 inches. And those are all measured in the diagram already. A hole in the shape of a cylinder with a radius of 1 inch is drilled through the entire length of the rectangular prism. What is the approximate volume of the remaining solid in cubic inches? Well, I started with a rectangular prism, and then I took out a small cylinder from the middle. So if I could find the volume of both of those pieces and then subtract them, I'd be good. I'll start with the rectangular prism, because that's a little bit easier to see. The base is 4 by 4 times how far it goes back, which is 6. So the volume of this prism would be 96 inches cubed. The volume of the cylinder, however, well, remember that formula is pi r squared times the height. They tell me the radius was 1 inch. Again, the question is, what's the height of the cylinder? And if it goes all the way through this rectangular prism, the other side of the cylinder must be 6 inches away, because the hole would be on the back of the block here. Picture like a cylinder laying down again, where your height between your bases would be 6 inches. So the volume of the cylinder is about 6, well, it's exactly 6 times pi, or if I type it into my calculator, it's about 18.8496 inches cubed. And if I subtract those, you get something that's closest to 77 inches cubed. Number 8. The water tower in the picture below is modeled by the two-dimensional figure beside it. So this is like a cross-section of this water tower where it's cut, right down the middle, and then I show you the side of it. Let C be the center of a hemisphere, and let D be the center of the base of a cone. If AC is equal to 8.5 feet, BF is equal to 25 feet, and the measure of angle EFD is 47 degrees, determine and state to the nearest cubic foot the volume of the water tower. Well, there's 3 figures here. There's a half of sphere, hemisphere, a cylinder, and a cone. Let's start with the piece that's easiest to work with. For this hemisphere, the formula for a regular sphere is just 4/3 pi r cubed. So if I take half of whatever that number is, I would get the volume of the hemisphere. So it would be helpful to know what the radius is, and I could substitute in. In this case, I could see in the picture the radius, the distance from the center to the edge. It's already 8.5 feet. So if I substitute that in for the radius, 4/3 pi times 8.5 feet cubed, and take half of all that, as long as you substitute that into your calculator carefully enough, you should get something along the lines of 1,286.22 cubic feet. Now, if I work with the cylinder, remember the volume formula for that is pi r squared times the height. The radius, consider that BC and CA are both radii of that hemisphere. So the radius BC, picture if you swing AC up that way, would also be 8.5. So pi times the radius of 8.5 squared times the height of the cylinder, which is 25 feet. The volume of the cylinder, again, if I type this straight into my calculator, is about 5,674.502 cubic feet. The last part I need to deal with is the cone, which is 1/3 pi r squared times the height. Well, I could slide that 8.5 up to say that my radius of the cone is 8.5, but the problem is I don't yet have the height of the cone, ED, but they did give me that acute angle there. And 9 times out of 10 when I'm given an acute angle, I want to be thinking this is probably a trig problem or a SOHCAHTOA problem to help me solve for that missing side. So if I just picture that right triangle with a 47-degree angle, an adjacent side of 8.5, and an opposite side that we're looking for, That sounds like a tangent problem. Of the tangent of 47 degrees is equal to my opposite side divided by my adjacent. I can put this over 1. I can cross multiply. And again, make sure your calculator is in degree mode for this. You should get that the height of the cone is about 9.115 feet. So when I go to substitute into my formula, 1/3 pi r squared times the height, my radius is 8.5, that's what I'm squaring, and my height is that 9.115. Notice I gave myself 3 decimal places. I know I'm rounding to the nearest cubic foot, so I like to normally go out 3 decimal places more than what I would need. When I type that into my calculator, I get about 689.641 cubic feet. The total volume of this water tower would be the sum of all of these, rounded to the nearest cubic foot. If I add those 3 volumes we calculated, the bottom part, this half a sphere, the middle part, the cylinder, and the top part, the cone, that's the amount of cubic feet of volume in this water tower. Now let's say the water tower was constructed to hold a maximum of 400,000 pounds of water. If water weighs 62.4 pounds per cubic foot, can the water tower be filled to 85% of its volume and not exceed the weight limit? Well, this would be the entire volume, and if I only want to consider what 85% of the volume is, I can multiply that number by 0.85. So if I do that, I find that 85% of the volume would be 6,502.5 cubic feet. And if water weighs 62.4 pounds for every cubic foot, I can multiply that by 62.4 pounds for every 1 cubic foot. Now, I know it's multiplication instead of division because when I multiply them, feet cubed divided by feet cubed, it cancels. And the only unit I'd be left with is pounds, and I'm trying to get a number in pounds. So if I multiply those two, I get that equals 405,756 pounds. So if they're asking me, would it not exceed the weight limit, consider that this number is greater than 400,000 pounds. So it cannot be filled 85% of the way. Otherwise, it would be too much and the water tower wouldn't be able to hold that weight of the water. Number 9. A regular pyramid has a square base. So picture I'm doing this in 3 dimensions. It's a square base. Pyramid goes straight up. Comes to a point at the top, has a height. The perimeter of the base is 36 inches. That's the sum of all the sides. The height of the pyramid is 15 inches. What is the volume of the pyramid in cubic inches? Well, the volume formula for a pyramid is 1/3 the area of the base times the height of the pyramid. I don't know the area of the base. I only know the perimeter is 36. But because it's a square, and all of the sides of a square base should be equal, if I divide that 36 by 4, I can find that each of those side lengths of the square base should be 9. Which means if I multiply length times width there, I'd find that the area of the base is 81 inches squared. So that's the number I'm going to plug in for big B. They told me the height of the pyramid was 15, and if I type all that into my calculator, I find that it's 405 for the volume of this pyramid. Number 10. Ian needs to replace 2 concrete sections in a sidewalk, as modeled below. Each section is 36 inches by 36 inches and 4 inches deep. He can mix his own concrete for $3.25 per cubic foot. Well, keep in mind they gave me everything in inches, so if I want a volume in cubic feet, let me convert these real quick. Okay, 36 inches divided by the 12 inches for every foot would be 3 feet. So that unit is 3 feet. That unit is 3 feet across, and this 4 inches deep. Well, that's not a nice enough number, so I'll leave that as 1/3 feet. Right, so I'll find, this looks like a rectangular prism to me. I'll find the volume of one of them. 3 times 3 times 1/3, length times width times height. So the volume of one of my prisms is 3 cubic feet. But Ian has 2 concrete sections that we see here. So they're right next to each other. So if I multiply that by the 2 that we have, he really has 6 cubic feet of volume that he's buying concrete for. And if he can mix it for $3.25 for every 1 cubic foot, I can multiply those, again, because the units would cancel here. So 6 times 325 would be $19.50. And you'll know if you divided when you should have multiplied, or if you made some sort of calculation error, because your answer that you get should be somewhat reasonable. That if somebody's replacing 2 pieces of their sidewalk, yeah, it could be about $20. If I get something extraordinarily high, maybe think about your operations and what mistake could have occurred. Number 11. A hemispherical water tank has an inside diameter of 10 feet. Well, let me draw it. So it's like half a sphere, and it's got a diameter all the way across at 10. If water has a density of 62.4 pounds for every cubic foot, what is the weight of the water in a full tank? Well, in order to do that, I would need to figure out the volume first. And the volume formula is 4/3 pi r cubed, but it's a hemisphere, so I would divide that number by 2 when I get it. And if the diameter is 10, the radius would be half of that, or 5. So the volume equals 4/3 pi times 5 cubed, all divided by 2 is about 261.8 cubic feet, again, because they gave me that diameter in feet. So if I wanted to figure out what the weight would be, I could multiply the volume by the density. One way to think about that is, again, we could see the units cancel. You might remember from earth science, you had a density equals mass over volume formula, which you always could use as well. Density is 62.4, the mass is what I'm solving for, that's the same thing as weight, and the volume is 261.8. So you'll notice if I put 62.4 over 1 and I cross multiply here, I would in fact just multiply these two numbers to get a value for the mass. And you should get about 16,336 pounds. Number 12. A wooden cube has an edge length of 6 centimeters and a mass of 137.8 grams. Let's see, a cube looks something like this. All the edge lengths are equal, so all of the edge lengths, 6 wide, 6 long, and 6 tall. Determine the density of the cube to the nearest thousandth. Well, like we just talked about, one way to find density is to divide the mass by the volume. I was given the mass, but I don't necessarily know the volume yet. So since this is a prism, I can just multiply length times width times height to find that my volume is 216 centimeters cubed. And if I divide the mass by that, my mass I was given in the problem to be 137.8 grams divided by 216 centimeters cubed. In my calculator, when I divide those, I get about 0.638, and I'll just rewrite my units, grams over centimeters cubed. So that's my density, I determined that. And it wants to know which type of wood the cube is made of using the density table. Well, I notice this number appears for ash, that 0.638 is a density, so it must mean my cube is made of ash because that's the range it falls into.